Welcome back, Math 111. I am going to continue our practice exam review. These will be questions 11 through the end of the test. All right, so a random sample of size n equals 20 from a normal distribution with sigma equal to 4 produces a sample mean of 7. So the first question is check the requirements. Is X bar distribution normal? Explain. It says it is a normal distribution and sigma is known. That's actually printed on your practice exam, so I won't rewrite it. Part B says, compute the sample test statistic, all right? That's code word for Z or T. Since we know sigma, we know that we're using Z. So Z equals X bar minus mu over sigma divided by the square root of n. So 7 minus 6 over 4 divided by the square root of 20, which is 1.12. Okay? So that's my sample test statistic. They had told us in that portion that H naught, the null hypothesis, mu was equal to 6. So that's where I got mu from. It was given. For part C, it says if H1, the alternative hypothesis, is not equal to 6, so that means it's two-tailed, right? So I have two tails. And since I'm using Z, I know I'll have to multiply times 2. You already computed the p-value. So, or you computed Z, now find the p-value. So the probability that Z is less than negative 1.12. Now, how did I know to use the negative? Well, I could have done it a couple different ways. But if this Z value is 1.12, then this one is negative 1.12, right? And it's symmetrical, so I can just find the p-value from that side. So the p-value for Z equal to negative 1.12 is 0.1314. And I need to multiply both sides by 2 because it's two tails. And I find that my p-value is 0.2628. All right, part D says, for the level of significance of 0.05 and the hypothesis from parts B and C, do you reject or fail to reject? So as usual, write p-value alpha. My p-value is 0.2628. My alpha is, what was that? Did I write it down? Oh, 0.05, it was given in this one, sorry. So I see that this part is bigger, so I failed to reject. And I will do all multiple choice. So this problem had everything written out, but we'll do all multiple choice. So part E says, explain at the 5% level of significance we cannot reject the null hypothesis. Okay, so that's that one. All right, I'm gonna walk over here in case someone still wants to read that. So number 12 says Pyramid Lake is in the, I don't know, it's an Indian reservation in Nevada. The lake is famous for cutthroat trout. Suppose a friend tells you that the average length of trout caught in Pyramid Lake is mu equals to 20 inches, right? You say, man, I can almost always get something that's about 20 inches long. However, the Creel survey reported that a random sample of 61 fish, so n equals 61, caught, the mean length was X bar equals to 19.3 inches. So they're saying, really, it's not 20, it's really a little smaller than that, right? We actually did a survey And the estimated, or the sample standard deviation is 3.2 inches. So that's S. So I know I'm going to use t-scores on this one. And alpha is equal to 0.01, okay? One of the things I want you to do is make sure you're writing things down. Make sure you're writing your variables down. Here, we'll just make a little switch here. Make sure you're writing your variables down as you go. So the first question is, what is the level of significance? State the null and alternative hypothesis. So my null hypothesis, mu is equal to 20 inches. My alternative hypothesis is, just a second, the average deviation is more than, so it says, is it more that's greater than 20 inches, right? And it's one tail, so we're talking about one tail, but we're using t-score, so make sure you use that. We're going to use the student's t distribution. Part B is we're going to use t, and the degrees of freedom equals 60, right? Because there were 61 fish caught, we subtract 1, that's my degrees of freedom. Part C is calculate the test statistic, so t equals x bar minus mu over s divided by the square root of n. So 19.3 minus 20 over 3.2 divided by the square root of 61 equals negative 1.708. Now, when we look up values on the t chart, since it doesn't contain any negatives, like that's built into the way the chart is designed. Now there are some extenuating circumstances, but we don't go there in this class. So know that you just can kind of ignore the negative at this point. Okay, I never say that, do I? Beautiful. So we want to find the p-value. So again, I go to degrees of freedom of 60. I look for 1.708 as a t-score. I run up to the column that says one-tailed, and I find that my p-value is between 0.50 and 0.025. Okay. So that's my p-value. And then the last question says, do you reject or fail to reject the null hypothesis? Well, I'm comparing this to 0.01. So when I compare this range of values to 0.01, they are always, I'm gonna make that really big. They're always bigger than 0.01. So I failed to reject. So your friend said, I get an average of a 20-inch fish no matter, anytime I fish in this lake. Somebody else said, we took a sample and it's really 19.3. Well, then we find out that really, that isn't a really good indicator. All right, let me do some erasing. Also might see which lights I can turn off. I see that there's quite a glare in my camera. I never know which, oh, that's too dark. Yeah, that's probably too dark. All right, we'll just leave it like that for now. I think it'll be fine. So the interpretation of this is at the significance level of 0.01, the data is not significant enough to reject the null hypothesis that the average length of trout are more than 20 inches. All right, number 13. So number 13, and again, our exam will be all multiple choice, so it'll be broken up a little bit different, but the same questions, I use the same kind of ideas, the same topics will be covered. So are America's top executive officers really worth all that money? One way to answer this question is to look at row B. the annual company percentage increase in revenue versus row A, the CEO's annual percentage salary increase in the same company. Do these data indicate that the population mean percentage, excuse me, increase in corporate revenue, row B, is different than the population mean percentage increase in a CEO's salary? We're going to use alpha equal to 0.05. My difference is going to be row B minus row A. And don't get hung up on what this means, but this makes sense that we could use our paired differences because we're looking at, CEO number 1, CEO number 2, CEO number 3. We're looking at each CEO and looking at how they increased the company's percent and what that percent meant for that CEO. So I did and again, you have a copy of this. I did all the differences, okay? So you have each one, you do the differences, and I need to find D bar, which is the average of all these differences, and then the standard deviation of those differences. So again, you know how to calculate mean and standard deviation, and that's all you have to do. So D bar is 3.78, S sub X is 8.71. And then part A says, what's the level of significance? That's 0.05. My null hypothesis, mu sub D equals 0. Remember, for paired differences, mu sub D is always 0. Always, always, always. And H1, mu sub D is not 0. All right, how did I know to use not? It says, do these indicate the population mean percentage increase in corporate revenue, row B, is different from the population mean percentage? So is different from, sometimes it says different either way, but it doesn't tell us bigger or smaller, it just says different. Okay, so there's our null and alternative hypothesis. We're gonna use the T distribution because sigma is unknown. So T is D bar minus mu sub D over S sub D over the square root of N, right? Remember, however, I also know that I can, because mu sub D is going to be 0, that'll help my math a little bit, 3.78 minus 0 over, oops, that should be a D, over 8.71 divided by the square root of, what was N? Oh, I have to count. 1, 2, 3, 4, 5, 6, 7, 8, 9. N is 9, because there's 9 values, right? There's 9 differences. When I do that math, I find it's 1.30. All right, that's my t-score. Then I go to my t-chart and I look up a p-value. Now you'll notice on the answer key, there's an exact p-value that you do not have to do. Some students like to use their calculator or Excel, or there's a website. You will typically give me this range of values. That's all you're gonna give me. So for part D, it's 0.200 less than p-value, which is less than 0.250. And then I love for you to sketch. So this was two-tailed, okay? So these two tails together, that's what it looks like. Again, this is a t-chart. And let's see, base, do I fail to reject or reject? So if I compare the p-value to alpha, alpha is 0.05. Well, alpha is always less than. So that means I fail to reject. So at the 5% level of significance, we fail to reject the claim that there is a difference in the mean percent increase in corporate revenues and CEO salaries. All right, study hard.